In this video, we are going to solve this problem number 8. In the previous video, we have seen the expressions for direct shear stress and the horizontal shear stress in type 2 bracket connection. We know what is the difference between the type 1 bracket connection and type 2 bracket connection, right? Uh, the classification of the bracket connection in type 1 and type 2 is based on the plane of weld and plane of load. If plane of weld and plane of load are parallel to each other, or the weld and load are in the same plane, then it is type 1. And if the load is acting one plane and weld is on the other plane, and both these planes are perpendicular to each other, then you can call this connection as type 2 bracket connection. So in this question, as you can see here, this is the weld. Okay, this is the vertical plane. This plane is vertical and also perpendicular to your screen. And there is also another plane, uh, see here, on which this load is acting 140 kilonewton. This 140 kilonewton is acting on a vertical plane which is parallel to your mobile or desktop screen. So you can say that even though the vertical load and the weld are on vertical planes, these two planes are perpendicular to each other. So because of this load 140 kilonewton which is acting at 100 mm in this particular problem, we are going to see direct shear stresses and also vertical shear stresses, horizontal shear stresses due to bending. Okay, so what we are going to do as a part of this bracket connection is what is important. Okay, అసలు మనం ఏం చేస్తాం ఈ బ్రాకెట్ కనెక్షన్ అంటే, సో బ్రాకెట్ అంటే దిస్ ఇస్ ది బ్రాకెట్, రైట్? దిస్ ఈస్ ది బ్రాకెట్ ప్లేట్ and this is the column ISHP 300. This is an I section. So I section is being used as a column and we have a bracket plate. I mentioned you earlier that bracket plates are meant to transfer the load to the column from something else. For you to understand, let me just take an example here. See, there is a column here. There is a column here beside that, and there is another column here. These are all in a straight line. Okay, and therefore there is a beam attached to it connecting these two. There is a beam connecting these two. Okay, this is a part of a shed. You can take as a steel structure. Okay, you mostly see in industrial structures, right? Industries, right? కొన్నిసార్లు మనం చూస్తే there is some kind of load always acts on this bracket. Some load has to be transferred to this column because of flooring or any other industrial equipment like cranes, girders. They have to come onto this. So the load that is falling on the slab or on the floor has to be transferred to the beams and columns. Okay, especially to the columns. Okay, so now what happens is, so this slab will rest on these brackets. Okay, so we use these bracket connections to transfer any kind of load onto the column. Okay, it is going to be a little bit tricky, right? Okay, when you see the steel structures and this concrete structures, the load transferring from one element to one element, is going to be a little different. Okay, we need additional things, right? In RCC structure, you do not need any plates or anything, right? But in case of steel structures, you come across these kinds of uh, additional elements. Okay, so let us solve this problem. Let me read out the question for you. A bracket plate 10 mm thick, the thickness of the bracket plate is 10 mm, is used to transmit a reaction. Reaction is nothing but a load or a force, something like that. So 140 kilonewton at an eccentricity of 100 mm as shown in this figure from the column flange as shown in this figure. Design the weld. So you have to design this weld. So you know what is design of a weld, right? I told you from beginning. సో వెల్డ్ని డిజైన్ చేయటము అని అంటే ఏంటి అంటే ఫైండింగ్ అవుట్ ది వాల్యూ ఆఫ్ ఎస్, ఫైండింగ్ అవుట్ ది వాల్యూ ఆఫ్ టీ అండ్ ఫైండింగ్ అవుట్ ది వాల్యూ ఆఫ్ ఎల్డబ్ల్యూ. సో సైజ్ ఆఫ్ ది వెల్డ్, effective throat thickness of the weld, and the length of weld required. మూడింటిని మనం కనుక్కోవడమే. ఓకే, క్యాల్కులేషన్ ఆఫ్ దీస్ త్రీ థింగ్స్ ఈజ్ నథింగ్ బట్ డిజైనింగ్ ది వెల్డ్. ఓకే, వెల్డ్ని డిజైన్ చేయడం అంటే ఈ మూడింటిని క్యాల్కులేట్ చేయటమే. సో వీఆర్ గోయింగ్ టు ఫైండ్ దీస్ త్రీ థింగ్స్. ఓకే, and finding out this S and T is very simple thing. Okay, you know that. Okay, let me just go quickly. Okay, so first step, okay, this is what you do. This is how you design a weld connection in type 2 bracket connection. Okay, very simple problem. Okay, so let us take the fillet weld size as 6 mm. The reason for taking this as 6 mm, you know that, right? We have seen in the previous problem that S minimum, okay, S minimum is obtained from IS 800, okay, based on thickness of thinner plate. Okay, see here, సైజ్ ఆఫ్ ది వెల్డ్, మినిమం సైజ్ ఆఫ్ ది వెల్డ్ దేని మీద మనం డిపెండ్ అయి తీసుకుంటాము అంటే ఏవైతే రెండింటిని మనం వెల్డ్ చేయడానికి ప్రయత్నిస్తామో ఏదైతే కలపడానికి ట్రై చేస్తామో అందులో సన్నంగా ఉన్న మెటీరియల్ని మనం కన్సిడర్ చేయాలి, దాని థిక్నెస్ ముందుగా. ఓకే, యూ హ్యావ్ టు కన్సిడర్ ది టూ మెంబర్స్ విచ్ యు ఆర్ ట్రైంగ్ టు వెల్డ్. ఓకే, and take their thicknesses and consider the lesser thickness value. Let me give you this here. See, ISHB 300 is nothing but an I section, right? So from steel tables you can get the thickness of this flange, right? See here, this bracket plate is being welded to the flange, right? So when you go through the steel books for this I section, you will find out the thickness of the flange, right? Something, okay, it is something, right? And the gusset plate thickness is already given here, 10 mm. So you can go through the table from IS 800 and find out what is the minimum size of the weld. Okay, ఫ్లేంజ్ థిక్నెస్ని ఇంకా బ్రాకెట్ ప్లేట్ థిక్నెస్ రెండింటిని మనం చూసి ఈ రెండిట్లో ఏది తక్కువ అయితే అది మనం కన్సిడర్ చేస్తాము. ఆ వాల్యూని తీసుకెళ్ళి IS 800లో టేబుల్ నెంబర్ 21 you will find out what should be the minimum thickness of the weld. Okay, you know that it is something like 3 mm. Okay, so now this is this minimum. What is X maximum? X maximum is nothing but thickness of thinner plate minus 1.5 mm. For example, let 10 mm. ఇప్పుడు ఫ్లేంజ్ యొక్క థిక్నెస్, బ్రాకెట్ ప్లేట్ థిక్నెస్ రెండింటిని కన్సిడర్ చేస్తే ఒకవేళ బ్రాకెట్ కనెక్షన్ యొక్క థిక్నెస్ తక్కువ అనుకుందాం. సో 10 mm అనేది థిన్నర్ ప్లేట్, ఫ్లేంజ్ థిక్నెస్ 10 mm కంటే ఎక్కువ ఉంది అనుకున్నాం. ఓకే, ఇప్పుడు థిన్నర్ ప్లేట్ థిక్నెస్ని మనం కన్సిడర్ చేయాలంటే 10 mm. సో ఇప్పుడు అందులో 1.5 మైనస్ చేస్తే ఎంత అవుతుంది? 8.5 mm, రైట్? సో 8.5 mm is considered as S max and 3 mm is the S minimum. In between these 3 mm and 8.5 mm, you can consider any value as the size of the weld. Okay, so when you decide the value of S, it is not purely on assumption, it is through the code. You have to find out what is S minimum and then S maximum and choose a value in between these two. And practically we will never go below 6 mm. Okay, I mean, sir, you said this can be above 3 and below 8.5, right? Why not choose 4 mm? But in practical case, we go with the 6 mm as the minimum size of the weld. We do not go under that. Okay, so once we know the size of the weld, you can calculate the effective throat thickness, T E. Okay, T E. T is equals to K times of S. And what is this K? K is a constant which you can get from IS 800 again. Okay, K value depends upon the angle between the two elements. See here, in this particular case, the flange of the eye section and the bracket plate are perpendicular to each other. That is 90 degrees. So, based on that angle, the K value is obtained from the IS 800 code. So, if the angle is 90, the value of K is 0.7. So, 0.7 times of S and 6, 0.7 into 6, 4.2 mm. So, you found out two things, S and effective throat thickness. The other important thing which is a part of design is calculating the length of the weld. Okay, let us come to that part. Okay, so now in this problem we have an additional term. Of course, I have discussed this about this in the previous video, but let me just remind you, depth of the weld. See here, let me show that in this figure itself. That would be good for you. Right, let me just correct this. Right. Okay. So this is the weld. Okay. When I say what is the length of the weld, that is nothing but this, isn't it? But see here, this weld is vertical weld, right? పై నుంచి కింద వరకు లేకపోతే కింద నుంచి పై వరకు చేస్తాం, verticalగా చేస్తాం కాబట్టి we call this as the depth of the weld. Okay, there is nothing more than that. Okay, so this is depth of the weld. But remember, the weld is done on both sides of this bracket plate. ఇటువైపు అంటే మీకు కనబడుతున్న వైపు and back side on the other sides of the bracket plate also it is being done. So if this is the D, depth of the weld, what is the length of the weld is going to be 2 times of D, isn't it right? Okay, so you have to remember that. So now let me go into the previous thing here. See, what we are going to do now here is, first thing we are going to find out what is LW. Okay, అంటే LW calculate చేస్తాం అంటే అయిపోయిందా అప్పటితో అంటే no. After calculating LW, we have to make a check. What is that check? This check, what is that? The equivalent stresses or the resultant stresses are less than the strength of the weld or not. You have to check that. So we have two more steps here. So let us start with this. See, in order to calculate D, this is the equation. D is equals to root over 6m by 2t FWD. So you may be wondering how we got this equation. Actually, this is the equation from this bending stress. I mean horizontal shear stress or bending stress. FB value is equals to 6PE by 2t d square. That implies d square equals to 6m by 2t FB. D is equals to 6m 2t FB. But here, see here, What is FB? FB is the bending stress due to load. Okay, but while calculating the D value, that is the depth of the weld, okay, what we are going to do is we are going to use the same equation, but with a change. What is that? We are going to replace this bending stress with 80% of FWD. What is FWD? Okay, let me write this here. FWD, this is nothing but design strength of the weld. సో ఇందులో 80%ని మనం ఇక్కడ ఎఫ్బిలో రిప్లేస్ చేయాలి. కాబట్టి ఇప్పుడు ఈక్వేషన్ ఏమవుతుందంటే డి ఈక్వల్స్ టు 6m/2t ఇంటూ 80% ఆఫ్ FWD. So that is what I am going to do. So first I am going to calculate FWD and then see here. Okay. FWD, of course, 80% of design strength of the weld. Fu by root 3 gamma mw is the strength of the weld. And the strength of the weld లోనే మనం 80%ని మనం ఇక్కడ తీసుకుంటున్నాం అన్నమాట ఈ ప్లేస్లో. ఓకే, దిస్ ఇస్ నథింగ్ బట్ 80% ఆఫ్ దిస్ Fu by root over 3 gamma mw. Okay, of course you know what is the value of Fu. Fu అంటే మళ్ళీ తెలుసు మీకు, దట్ ఈస్ ది అల్టిమేట్ స్ట్రెంగ్త్. అంటే మన పేరెంట్ మెటీరియల్, ఏ మెటీరియల్ అయితే మనం వెల్డ్ చేస్తున్నాం ఆ మెటీరియల్ యొక్క అల్టిమేట్ స్ట్రెంగ్త్ని, వెల్డ్ యొక్క అల్టిమేట్ స్ట్రెంగ్త్ని రెండింటిని మనం కంపేర్ చేయాలి. విచ్ ఎవర్ ఈజ్ లెస్ ఆ వాల్యూని Fu కింద తీసుకోవాలి. యూ హ్యావ్ టు టేక్ ది లెస్సర్ ఆఫ్ ది ultimate strength of the weld and ultimate strength of the plates connecting here. So in this case it is 410 Newton per mm square ultimate strength, and this is a shop weld, therefore the factor of safety is taken as 1.25. If it is not given the question, you can just make an assumption, either it is a shop weld or a field weld. And see, FWD is equals to 80% of that value is 151. So I'm substituting, now you got the value of depth D, that is 280 mm. So this is not the length of the weld. Length of the weld is 2 times of D. Okay, so D is the depth of the weld. So this is the length of the weld on each side. ఒక సైడ్ మనం చేయాల్సింది వెల్డ్ లెంత్ D, అదర్ సైడ్ సేమ్ మళ్ళీ చేయాలి, అట్లా సేమ్ వాల్యూ. సో 2 times of 280 is the total length అవుతుంది. Okay, but now let me check this weld. Okay, first consider, you need to consider only one weld. Let us consider only one side of the weld, because even one side of the weld fails, it fails. Okay, connection is failed. So consider only one side of the weld. Okay, so now, or you can consider both also. Okay, that would be better. Okay, we can do it in the single step. So consider 2 times. So LW is equals to 2D, అంటే 2 into 280. Okay, remember 2 into 280 mm. So now we know this FA. FA is the direct shear stress. What is direct shear stress? Load acting by effective area. Effective area is nothing but TE into LW. So TE into LW అంటే 2D. So 2TD, 2TT, this is E. So now on substituting, this is the direct shear stress or vertical shear stress. Now what is the horizontal shear stress or the stress due to bending? FB 6PE by 2T E D square. So 6 load, and this is eccentricity, effective throat thickness, and D depth of the weld. So now this is the value. Now let us find out the resultant value. We get 140.75 Newton per mm square. Now you have to check this. Okay, you have to check, is Fe less than or equals to Fu by root 3 gamma mw or not. So on calculation of Fu by root 3 gamma mw, the value will be 189.37. Okay, Fu is 410, this is 1.25. So just on substitution, you get 189.37 and Fe 140. So you can clearly see that the resultant stresses due to load on the weld are less than the actual strength of the weld. So weld is not going to fail. వెల్డ్ అనేది ఫెయిల్ అవ్వదు. వెల్డ్ స్ట్రెంగ్త్ ఎక్కువ వెల్డ్ మీదకి వస్తున్న స్ట్రెసెస్ కన్నా, కాబట్టి వెల్డ్ ఫెయిల్ అవ్వదు. ఓకే, సో దిస్ ఈస్ ద చెక్. ఇఫ్ దిస్ చెక్ ఫెయిల్స్, వాట్ హ్యాపెన్స్? ఓకే, వాట్ యూ షుడ్ డూ ఇస్ యూ హ్యావ్ టు గో టు ది ప్రీవియస్ స్టెప్స్ and you have to change the size of the bracket weld. Okay, so if you wanted to change the size of the weld, you again have to change the size of the bracket plate also. You have to increase it. Okay, so everything changes. Okay, this is the check that helps you to check this. So in the next video, we are going to discuss about this problem number 9. Okay, this is a similar problem, same problem, and we are going to solve it. Okay, so I hope you understood this, and let me see you in the next video. Thank you.